Good evening friends, all of you. Today we are going to study about module number 2, Big M method. I hope you have listened the lecture about the simplex method and you have also solved some numericals about the simplex method. Unless and until you know the basics about the simplex method, it is very difficult for you to understand the Big M method. So I request you, all of you, so before listening this lecture on Big M method, everybody should at least once listen the lecture on simplex method. So it is simplex method, the Big M method, or the dual simplex method, or the dual theory. All methods are different forms of simplex method. So once you know the basics about the simplex method, all other methods like the Big M method, the two-phase method, or the dual simplex method look very easy. So to tell the difference between the simplex method and the Big M method, I would like to tell you that simplex method is a method in which the LPP, the given LPP, will be using the constraint equations of less than or equal to only. Or in other words, the LPPs having less than or equal to signs, the constraint equations having less than or equal to signs can be solved by simplex method. But if the constraint equations are having greater than or equal to signs or only equal to signs, then we cannot solve this LPP by the simplex method, because in such form of LPPs where the constraint equations are having greater than or equal to sign or is equal to sign, we cannot form an identity matrix in the first iteration table of the simplex. So in such equations, in such LPPs where the constraint equations are having greater than or equal to sign or equal to sign or a mixture of all greater than equal to, less than equal to or equal to signs, we have to go for the Big M method. So Big M method is a method, it is called as Big M method because it makes use of some form of artificial variables. So therefore, let us take an example of an LPP so that I can easily explain you how to solve the given problem by simplex method. Okay friends, we will be starting with the Big M method. So, Big M method numerical. An example is shown here. Maximize z equal to minus 2x1 minus x2 subject to the three constraint equations are there. The first constraint equation is 3x1 plus x2 is equal to 3. Second is 4x1 plus 3x2 greater than or equal to 6. The third constraint equation is x1 plus 2x2 less than or equal to 6. x1, x2 are greater than or equal to 0. Now if you see this LPP, there are three constraint equations. All the three constraint equations are not less than or equal to. So the first equation is equal to, second is greater than or equal to, and the third is less than or equal to. Hence we can go for the Big M method. The first step is now convert the given LPP into standard form. So as you all know, the standard form is the objective function should always be of maximization type. So it will be maximize z dash is equals to minus 2x1 minus 2x2. This I will tell you later on what I have added here. So subject to the constraint equations. The first constraint equation is 3x1 plus x2 plus a1 is equal to 3. Now since the constraint equation is having equal to sign, here neither we can add the slack variable nor I can subtract the surplus variable. So equations which are having equal to sign, in such equations we have to add one artificial variable a1. So this is a positive artificial variable a1 is equal to 3. The second constraint equation is having greater than or equal to sign. So if the equation is greater than or equal to sign, we should subtract the surplus variable minus s1. And since this is negative, I am going to add a positive artificial variable. Only because this is negative, I am adding a positive artificial variable a2 is equal to 6. Once if I take a1 in the second equation, I have to take a2. If you see third constraint equation is equal less than or equal to 4. In such equation, as you all know, in simplex we have done x1 plus 2x2 plus slack variable s2 is equal to 4. So if the constraint equation is having less than or equal to sign, we add a slack variable. So s1 I have taken in the first equation, so I take once again s2. So therefore, once again I will repeat here, just here this is very important. If the constraint equation is having equal to sign, less than or equal to sign, add slack variable. If it is having greater than or equal to sign, such as in equation 2, then subtract the surplus variable, add the artificial variable. Okay, and when the constraint equation is having is equal to sign, then in such a case we have to add only artificial variables, and the variables should not be repeated. Okay, x1, x2, s1, s2, a1, a2 are greater than or equal to 0. Now, after this, we have to assume. So, big M method also starts with an assumption. So, by assuming the value of x1 is equals to x2 is equal to 0, the decision variables x1, x2, the value is assumed as 0. If you assume this value as 0, we get z maximum is equal to 0 plus 0 s1 plus 0 s2 minus ma1 minus ma2 minus ma1 minus ma2. Okay, so what is this 0 s1 0 s2 minus ma1? So if you come back to the objective function, we see that all the slack variables or all the surplus variables, they should always be added in the objective function with 0 coefficient. The slack and the surplus variables should always be added in the objective function with 0 coefficient, whereas artificial variables a1, a2 should always be added in the objective function with minus m coefficient, where m is a penalty, m is a huge number, it is a big number. So minus m a1 minus m a2. So these are always added in the objective function. So by assuming x1 is equals to x2 is equals to 0, we get z maximum is equal to this. So for this assumed solution, which we have seen in this simplex method, so for the solution which we have assumed 0, for that we have drawn the first iteration table. So this is the first iteration table which I have drawn as we have drawn in the simplex method. So here Cj means these are the cost coefficients, minus 2, minus 1, 0, 0, minus m. We have x1, x2, s1, s2, these values we have written here, and all this matrix is about the constraint equations, the coefficients of the constraint equations, and this value b3, 6, 4 is the RHS of the constraint equations. And here we write a1, a2, s2. How to write this a1, a2, s2? From every equation we have to write one positive variable. From every equation we have to write one positive variable. In equation number 1, a1 is positive, so I have written here a2. From equation number 2, a2 is positive, I have written there a2. From constraint equation number 3, s2 is positive, I have written in the same sequence a1, a2, s2, and they are coefficients in the objective function, minus m, minus 1, m, 0. These are the coefficients of these variables in the objective function. So after writing this matrix completely, as usual, we know that we have to find out the value of Ej and Ej minus Cj. So Ej we know minus m into 3 minus 3m plus minus m into 4 minus 4m plus 0. So minus 3m minus 4m, it will be minus 7m. Here in the second column, minus m into 1 is minus m plus minus m into 3 is minus 3m. This is 0, so this is minus 4m. So like this we have to find the values of Ej. So after finding out the values of Ej, we have to find out Ej minus Cj. Minus 7m minus of minus 2 is plus 2. So find out the values of Ej minus Cj. So once you find out the values of Ej minus Cj, see which is the greatest negative number of Ej minus Cj. So as I have explained in the simplex method, the greatest negative number which is greatest number with negative sign. So minus 7m is the greatest negative number. So this will be the key column. So put a dotted line for the key column. Find the key column, find the key row, and find the key element for this matrix as explained in the simplex method. So to find out the key row, we have to take the minimum ratio of B and KC column, 3 by 3 or 6 by 4 or 4 by 1. Whichever is minimum ratio, that will be the key row. While considering the key rows, negative ratios should not be considered. Please keep in mind, negative ratios should be neglected. Only the minimum positive ratio should be taken as the key row. The element, intersecting element of key column and key row will be called as the key element. So find out the key element and go to the second iteration table. So once you find out the key table, draw the second iteration table and don't fill the values here. So first find out the key element. So as per the simplex method, key element should always be 1 and the other elements in the key column should be 0. Other elements in the key column should be 0, which I have done here in the second table. So how to do that? Since the key element is 3, we all of us know, divide the first row by 3. So R1, if I divide by 3, I will get here 1. So 1 by 3, 0, 0, 0. I have R1 by 3. So the first row elements have been changed. Now I want to make this number 0, this number 0. R2 I want to make 0 with respect to key element unity. So R2 is 4 minus 4 times 1. R2 minus 4 R1 dash. R1 dash means the second table's first row. So R2 minus 4 R1 dash. This rule I have to apply and I have to write the second table. This will become 0. This number 1 also I want to make 0. This is R3. So R3 with respect to R1 dash. R3 minus R1 dash. So this rule I will apply and I will prepare the second table. So in this manner I will fill all the values of the second table. The detailed explanation of this problem is given in the simplex method. So I told you before also, before coming to this big M method, go through the first simplex numerical and then come here, so that you will come to know how the calculations and the iterations can be proceeded. So after filling out the table here, once again we have to come over this side now. So where the key element is there in the first element, in the minus MA1 row, in column is minus 2x2. So in the second table, minus MA1 will completely go out and minus 2x1 will enter the second table. So in this place, minus 2x1 has come and minus MA2 has gone, correct? So this minus MA2 will completely leave the second table. See here, minus MA1. It is the outgoing variable. So the key element will remove minus MA1 completely from the second table. So in the second table now A1 is not there. So only A2 is there. So fill the second table. After filling the second table, find out the value of EJ and EJ minus CJ. So after finding out the values of EJ minus CJ, if all EJ minus CJ values are greater than or equal to 0, the solution is optimum. Otherwise, once again find which is the key column, key row and the key element. Since all the elements are not greater than or equal to 0, here some of the values are negative, so we have to find out what is the key column. So here there is only one negative number, so this will be the key column. So show a dotted line for the key column, find the key row and the key element. So after finding out the key element, draw the third table. A blank table you first draw, write the coefficients, write this EI, VB, X1, X2, S1, S2, B, etc. Inside the table, what you have to write is that, see here the table number 2, 5 by 3 is there. So this key element should always be unity. And these two numbers 1 by 3 and 5 by 3 should always be 0. So to make this unity now, R1 dash, R2 dash, R3 dash. R2 dash I want to make unity. So 5 by 3, if you want to make unity, you have to multiply by 3 by 5. So the rule I have written here, R2 dash into 3 by 5. Applying this rule to the whole row, the second row elements are changed. The second row elements are changed. Now this I want to make 0 with respect to key element unity. This I want to make 0 with respect to key element unity. Okay, so R1 dash I want to make 0 with R2 dash. So 1 by 3 minus 1 by 3 of this. R1 dash minus 1 by 3 of R2 dash will be 0 here. So apply this rule to the first row, get the new elements of the first row in the third table. This I want to make 0, R3. Okay, so 5 by 3 I want to make 0 with respect to this number 1. So 5 by 3 minus 5 by 3 of this. The rule I have written here. Using this iteration, fill the third row elements. So in this manner, fill the matrix of the third table. And on the left side now, where is the key element? The key element is here, 5 by 3. So the key element will replace minus MA2 and this will be replaced by minus 1x2 here. Minus 1x2 has come here, minus MA2 has gone. This minus MA2 will completely leave the table, outgoing variable. Minus MA2 is outgoing variable. This will leave completely from the third table. So in third table now, A1 and A2 column are not there. The iteration table has become small. So after writing the iteration table, find EJ, minus 2 into 1 plus minus 1 into 0 plus 0 into 0. Like this, find the values of EJs. Once you know the value of EJ, find out ej minus cj, ej minus cj, minus 2 minus of minus 2 is 0. We get the values of ej minus cj. If all values of ej minus cj are greater than or equal to 0, the solution is optimum, or we have to proceed further. Now in this table, since all ej minus cj values are greater than or equal to 0, the solution obtained in this table is optimum. So where is the optimum solution now? See the VB and V column. In the VB column, see how many decision variables are there, x1, x2. The value of x1 is the value of b here under b. So x1 is equals to 3 by 5. See the column VB and B. x1's value is 3 by 5, x2's value is 6 by 5. So x1 is 3 by 5, x2 is 6 by 5. So putting these values of x1 and x2 in the main LPP given, main objective function of the LPP given. What is the main objective function? Maximize z equal to minus 2x1 minus x2. In that, put the values of x1 and x2 and you will get the answer as minus 2 into 3 by 5 minus 1 into 6 by 5. Okay, so like this we will get the answer as minus 12 by 5 units. So here we complete the problem. Okay, thank you. So in this manner we can solve the LPP by the big M method. So friends, at the last, once again I would like to request you all that before solving the numericals by the big M method, first go through my lecture of the simplex method. So the basics and the detailed understanding of the big M method is given in my lecture number 1 of module number 2 simplex method. So first study the details in that problem so that you can easily do the problem on big M method. Okay, thank you.